Welcome back to the course on vibration. Today I'm going to do a problem. This was once asked in GATE. So the question is, here we have a massless rod and there is a mass at the end. You're asked to find out the natural frequency of the system. Okay, now let's see how we can go about solving this particular problem. Important thing is this is a massless rod. So there is no mass moment of inertia of the object for this portion. Okay, and the first question that you should ask when you start doing a vibration problem is there are how many degree of freedom. This is pretty obvious. This is a single degree of freedom system, because once we know the inclination of this particular bar, the total system is defined. We don't need any other parameter. Someone may be thinking we need the deflection of this. No, you don't need the deflection of this, because if you know the inclination of this particular, if you know this angle, then a times that angle will give you the displacement of this particular point. So this is a single degree of freedom. Then what kind of motion it is undergoing? This is where the principles you learned in kinetics will come handy. So this is undergoing pure rotation. I will call this point O. So this is undergoing pure rotation about O. Okay, now I know from my study of engineering kinetics that the equation should be sum up all the moments about the point O. It will be mass moment of inertia of the object about the point O times alpha, where alpha is the angular acceleration, d square theta divided by dt square, if I define this inclination as theta. Okay, now we have to figure out what is that single degree of freedom. Is it theta? Yes, it is theta. But I always told you we have to put the coordinate system at the equilibrium position. So this is not the equilibrium position. The system will be slightly inclined at the equilibrium position. See that static equilibrium inclination as delta. So this means as you release it, the system will be like this. I have exaggerated it. So at this point, if I sum up the moments about O, it should give me 0, because this is an equilibrium position. There won't be any forces. So this will be spring force acting at the equilibrium position will be K delta A, where K delta A will give me this distance. Okay, so the force will be K delta A. This will be mg. So if I take the moment about this point, K delta A into A minus, so this should be minus, because if I take this is the positive direction, this is in the negative direction, plus mg times 2A should be equal to 0. So I will call this as equation 1. This is for the equilibrium position. Now let's come back to this case. I'm slightly extending the system from the equilibrium position. So the equation, again the force at this point will be K times delta plus theta, right? Now I am slightly disturbing the system from the equilibrium position into again A. Okay, that will be the spring force acting on the system. Weight will be normally mg. I hope you know how I calculated the moment. This is the force, this is the momentum. Again here, this is the force, this is the momentum. Okay, now so using this equation, the moment about O is I0 into theta double dot. Okay, is equal to, this is acting in the opposite direction. If this is the positive direction of theta, this is acting in the opposite direction, delta plus theta A into, this is the force and the momentum is A, plus what is that? There is other force mg, weight. Mg is the force and 2A is the momentum. But this is K delta A square minus K theta A square plus mg 2A. But from equation 1 we know that this term and this term will cancel each other. So we will get I0 theta double dot plus k square theta is equal to 0. Okay, now what is I0? This is the mass moment of inertia of the system about this point. The road is massless, so there is no moment of inertia contribution from this road. There is only a mass which is sitting at a distance 2a, so it will be m into 2a whole square. The general equation is dmr square. Okay, since this is a discrete system, it will be 4m, so it will be 4m a square I will cancel plus k theta is equal to 0. Directly looking at the system, because when the equation was mx double dot plus kx equal to 0, the natural frequency in radians was omega n equal to root k by m. So here also I can say the natural frequency of this particular system will be k divided by 4m without doing any other calculation, because we know for this kind of a system this is a natural frequency, and for this kind of a system this should be the natural. Always remember that the units will be of this quantity will be radians per second. Thank you all.